Hello students and welcome to yet another video on foundation course for business statistics. In this video we are going to go through quartile deviation. Quartile deviation is one of the important measure of dispersion. In order to understand quartile deviation, we will first have to understand what quartiles are. Okay, so let us quickly understand what quartiles are. So if I have a series of data, okay, so and I arrange it in ascending order such that this is my smallest value and this is my largest value. So imagine this is my data and which I have arranged it in ascending order. Then we all know that if I can divide my data into two equal halves, right? Into two equal halves. That is 50% of my data lies to the left side and 50% of my data lies to the right side. And this is called as median. And we have seen how to calculate a median. Now remember, a median can be also called as quartile 2. So what we are saying is median is same as quartile 2. So quartile 2 has got 50% of the data to the left side and 50% of data to the right side. Now what is quartile 1? So if I take a median of left side of the data of quartile 2, so left side of the data, the median of left side of the data is nothing but Q1 and the median of right side of data is nothing but Q3, which means what I'm actually doing. So 50% of this left side data is further divided into 25% of the left side of Q1 and 25% in between Q1 and Q2. Correct? So this is how I have Q1, which is a median of this much of data. And similarly, Q3 is going to divide 50% of 25% of the data, okay, over here and 25% of the data over here, right? So that's how basically my Q1, Q2 and Q3 are three values which divide the entire series of data into four equal parts. This is how I divide the entire data into four equal parts. Now we know what is a formula of median. Formula of median was n plus 2 by n plus 1 by 2. So n plus 1 by 2th position observation is my median. Similarly, what is the formula for Q1? Q1, it is n plus 1 by 4th position observation, right? So this is my Q1, n plus 1 by 4th position observation. And what is Q3? Q3 is basically 3 by 4 into n plus 1th position observation. Okay, so these are my Q1, Q2, Q3. How do I calculate my quartile deviation? Quartile deviation is nothing but Q3 minus Q1 divided by 2. Remember, Q3 minus Q1 can also be called as interquartile range. So my quartile deviation is interquartile range divided by 2. And what is my coefficient of quartile division? Which is nothing but my relative measure of quartile deviation. And it is Q3 minus Q1 divided by Q3 plus Q1. Right. So further concretize our understanding, let us go through some examples. So basically, we have two examples. When we learned how to calculate median, we learned it both for odd number of elements and even number of elements. So similarly, I am going to quickly run you through both odd number of elements as well as even number of elements. So I have this data series which has got n is equal to 7. So these are odd number of elements. So what first step is to arrange this odd number of elements into ascending order. And what is my Q1 formula? Q1 formula is n plus 1 divided by fourth position. Remember, it is a position in the series, right? So what is that position? N plus 4. So 7 plus 1, 8 by 4, which is nothing but 2. So second position in the series. What is the second position in the series? It is 8. So my Q1 is equal to 8. What is my Q3? Q3 is 3 by 4 into n plus 1 position. So 3 by 4 into 8. So that is nothing but sixth position. So let's go to what is the sixth position? 5, 8, 3. So this is 1, 2, 3, 4, 5, 6. So Q3 is equal to 20. What is QD? QD quartile deviation 20. Q3 minus Q1, which is 20 minus 8 divided by 2, that is 12 by 2, that is equal to 6. And what is CQD? I suggest you folks, you know what Q1 is, you know what Q3 is, just use this formula and calculate coefficient of quartile deviation. Okay, what is, now let's calculate QD for even number of elements. Data series, you have 14, 10, 20, 18, 26, 24, 30, 34 and 30. I first have to arrange it in ascending order. What is n? N here in this case is 8 and n is even. So what is the formula for Q1? Q1 is n plus 1 divided by 4 position, which is nothing but 8 plus 1 divided by 4, which is nothing but 9 plus divided by 4, which is 2.25 fifth position. So 2.25 is nothing but between second and third. So I have to take the mean of 14 and 18. So 14 plus 18 divided by 2, which is 32 divided by 2, which is 16. So my Q1 in this case is 16. What is my Q3? Q3 is 3 by 4 multiplied by 9, correct? Because n is 8, 8 plus 1 is 9, right? So I have 27 by 4, which is nothing but 6.7. Now again, you know 6.7 lies between 6 and 7 position. So 1, 2, 3, 4, 5, 6. So 26 and 30 is what I have to take mean of. So 26 plus 30 divided by 2, which is 56 divided by 2, which is 28. So my Q3 is equal to 28. Now you know the formula of QD. QD is Q3 minus Q1 divided by 2. So I suggest you guys calculate Q3 minus Q1 divided by 2 and reply the answer both for QD and CQD in the comment box. Okay, so I will go through it, and if it's correct, I will respond back. Thank you so much. Let's move on. Now let's find out how to calculate quartile deviation for continuous grouped frequency distribution. Okay, so basically it is a group frequency distribution. How do we find Q1 and Q3? Well, we have to prepare a cumulative frequency table using less than cumulative frequencies. If you don't know what frequency table is, or what cumulative frequencies or less than or greater than cumulative frequencies, I suggest go through the previous videos on frequency table as well as cumulative frequency. We need to identify Q1 and Q3 classes. How do we identify Q1 and Q3 classes? Using cumulative frequency, okay, which is greater than or equal to n by 4 gives me Q1 class, and for Q3 class I use find cumulative frequency which is greater than or equal to 3n by 4. Okay, so this is how I calculate Q1 and Q3 classes, and once I got Q1 and Q3 classes, then I can calculate Q1 and Q3 using these formulas, which is Q1 is equal to L plus H divided by F into n by 4 minus C, where L is lower limit of Q1 class, H is class interval, F is frequency, N is total number of elements, that is sigma F, and C is basically cumulative frequency of the previous class. Okay, so let us quickly go through the example and it will be pretty clear from that. So this is the example finding quartile deviation and uh, coefficient quartile deviation for group frequency distribution. This is my data. I have put this entire data into a frequency table. This is a frequency table which comprises of X, F, and cumulative frequency. So these are my classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Needless to say, if you remember, these classes are of type exclusive type, and these are the frequency. My sigma F is nothing but 80. So how many elements are there in this data? So there are total 80 elements. So my n is equal to 80. So what is cumulative frequency, and how do we calculate cumulative frequency? It is less than or equal to CF, right? So what I do is I take 12 for second one. For first one it's 12. Second one, 12 plus 18 gives me 30. 30 plus 15 gives me 45. And how or why 12? If you remember, I have to ask question, how many elements are less than or equal to 10? So there are 12 elements which are less than or equal to 12. How many elements are less than or equal to 20? There are 12 of the previous class plus 18 of this class which are less than or equal to 20. So there are 30 elements which are less than or equal to 20, and so on and so forth. You have to go and calculate the cumulative frequency. Once you have cumulative frequency, you need to now find out what is Q1 class, or where do Q1, in which class Q1 belongs, right? So n by 4 is 80 by 20, n by 4 is 80 by 4, which is nothing but 20. So find out where would 20 lie. So 20 is greater than 12, and 20 is less than or equal to 30. So basically my 10 to 20 is my Q1 class. So my Q1 will lie in this class. Now let's calculate Q3 class. N is 80, 3n by 4 is 60. Now I have to find out where will my 60 lie, right? So 64 is greater than or equal to 60, right? So 60 is between 45 and 64. So this is my Q3 class. This is my Q3 class, correct? Now to find out Q1, right, all that I have to do is I know now which classes, what is Q1 class and what is Q3 class. So I need to now go on replacing the values of L. So L for Q1 is the lower limit of Q1 class, and that is 10. See, 10 to 20, lower limit of Q1 class. What is H? H is class interval. Class interval is also 10. F. What is F? F is the frequency of Q1 class, which is 18. Frequency of Q1 class is 18, correct? And what is C? C is cumulative frequency of previous class, which is 12. I have to take cumulative frequency of previous class, 0 to 10, which is 10. Similarly, so this is for Q1. I have to replace these values, okay, in this formula. I know n is equal to, already n is equal to 80. So when I replace this value, I get Q1 is equal to 14.444. Similarly for Q3, find out what's L. For Q3, this is the class, so my L is equal to 30. 30 is my lower limit of 30 to 40 class. My H is 10. My frequency for this class is 19. And what is C? C is basically cumulative frequency of previous class, preceding class, cumulative frequency of previous class, which is 45, because 10 to 20 to 30 is the previous class. Okay, so replace these values into this formula and we get 37.895. So now I have Q1 value and I also have Q3 value. You know the formula of QD, Q3 minus Q1 by 2. So replace these values and I get 11.726. Similarly, CQD, we know the formula Q3 minus Q1 divided by Q3 plus Q1, and that gives me 0.448, right? So this is how we calculated quartile deviation and coefficient of quartile deviation for grouped frequency distribution having less than or equal to cumulative frequency. With this, we come to an end of this video. In next video, we will learn yet another very important measure of dispersion, which is standard deviation. Till then, bye folks.